Hello, this is Shaokai Lin from UC Berkeley, and I'm thrilled to show you a quick demo of Lingua Franca, a polyglot coordination language that easily enables application developers to write deterministic, concurrent, and real-time applications using mainstream programming languages such as C, C++, TypeScript, and Python. In this demo, we're going to build a simple distributed database. This example is modeled after Leslie Lamport's 1984 paper using time instead of timeout for fault-tolerant distributed systems, where he describes a type of distributed database that can perform simultaneous updates across multiple nodes and respond to queries without having to consult other nodes in the network. A modern realization of this database is Google Spanner. These type of applications tend to pose serious engineering challenges for application engineers who are forced to deal with various race conditions, non-determinism, and bugs that may or may not show up. In Lingua Franca, deterministic coordination is handled in the execution semantics, even in distributed settings, removing burden for the application engineers. So in this demo, let's build a simple distributed database together and see Lingua Franca in action. Let's dive into it. So first of all, we are looking at the Lingua Franca IDE, where we have syntax highlighting, validators for writing correct programs, and also diagram synthesis for visualizing the system we're currently implementing. So you might notice that the first thing we're doing here is to declare a target language. In this case, we're declaring C as our target language. What this means is that when we later perform code generation, the code generator will in fact generate C code from this Lingua Franca program. And a target can also have target properties. In this case, we're setting the timeout of this program to be 10 seconds. And as you can see, time is a first-class object in Lingua Franca, and we can directly specify time in our target property. So as you can see, before I started recording, I wrote some modules that could be handy when we actually write up the database. So let me zoom in on the diagrams. As a database service, it will be handy to have a receiver that receives the HTTP messages that comes from our users. And it will also be handy to have the database component that performs the actual storage and update of the values that we're interested in. And it can also be useful to have senders to basically reply to our users with some HTTP responses. And lastly, it would be good to have a logger to log the current status of the database to keep track of some statistics. So these are the basic components. And what we're going to do right now is to dive into each one of them and explain some basic concepts behind these modules and some of the constructs that come from the Lingua Franca language. So let's dive into them. All right, so let's first take a look at the receiver, which is basically an HTTP server that listens for incoming user requests. So in Lingua Franca, developers can compose reactors. And in this case, you can see this reactor declaration, which is basically a class definition from which instances can be created later. And a reactor declaration can take parameters. And as you can see here, we have some database related parameters. And inside a reactor definition, user can create various constructs that's associated to this reactor. For example, we can create a timer. We can declare inputs and outputs of this reactor, and we can declare reactions. Let me first explain what timers are. So Lingua Franca uses discrete event semantics. This basically means that every signal in the runtime system has an associated timestamp. And what timer does is that a timer periodically fires signals with a period that is specified by the developer. In this case, this query period is being passed in when this class gets instantiated, and the default period is 150 milliseconds. And a reactor can have input and output ports. Using ports, reactors can interact with the external world. For example, by receiving values from input ports and by sending values through output ports. In this case, our receiver has two output ports, one named query and the other one named update. Both have a specific type related to the output port. A reaction is effectively a body of C code that gets triggered when certain signal is present. In this case, user can specify a reaction by first writing down the reaction keyword, and then the user specifies the type of trigger that this reaction is sensitive to, and the user further specifies a set of possible effects that this reaction can produce. In this case, the signature is saying that this reaction, after finishing the execution, can potentially write to the output port query. And what's inside this special bracket that I'm highlighting here is effectively the target code. So in this case, this is a line of C code that simply sets the query output port to the Boolean value true. Okay, let's now take a look at the database. So the database similarly is a reactor, and in this case we have three input ports that basically receives the value from our local updates as well as updates from other remote databases. And what's also interesting here is that we have a state variable. These variables are internal to each reactor, and here we are simply storing one integer as the record for our database. And similarly, this database has reactions that handles various updates to the record. And what's interesting here is that we have mechanisms like deadline and tardy handlers to handle various fault conditions related to timing, so that developers can use these mechanisms to build fault-tolerant applications. Let's now fast forward to Sender. In Sender, we can see that there is a new construct called logical action. So logical action is a mechanism that's used by reactors to schedule future activities, in this case 10 milliseconds later, and to control the advancement of logical time. The logger is quite straightforward. It listens for various inputs and controls its internal statistics. And now let's jump into putting everything together and write up a complete database. So let me quickly explain what's happening here. We're creating a platform reactor, which represents the database service, in which we're going to instantiate all of these modules that I showed earlier. And inside each platform, we're connecting these modules together using ports and connections. And lastly, we're instantiating multiple platforms so that we can have a distributed system. By adding a federated keyword, the compiler generates multiple executables as well. Okay, so this is what the final product looks like. As you can see, we have two identical database platforms connected together, and when each one of them gets an update, the other one will be instantly notified, and they will basically keep their internal states in sync. Let's see our database in action. Lingua Franca IDE conveniently compiles the Lingua Franca program for us, and as we can see, these databases are starting to receive queries and they're keeping each other in sync. Okay, so this wraps up the demo of writing a distributed database using Lingua Franca. Lingua Franca is also an open source project. If you're interested in learning more, feel free to check out our repo. And thank you so much for your attention.